and Hi, my name is Gareth Maddox, and I'm here talking about our advanced data mining project with my group members, Kavi Ravi and Caitlin Burke. So my application study was unsupervised learning, comparing 3 different cluster models, K-means clustering, DB-scan clustering, and expectation maximization clustering. And all 3 of these use the same basic architecture. First, the data is normalized, most of them using range transformation. Then the data is resampled, and all the nominal data values are converted to numerical before it's passed to the clustering model. And the first model used was K-means on the next slide. And this one was the easiest to run. And as you see from the results, it's plotted with each attribute versus the frequency of that attribute in each cluster. And this came out with 4 different clusters. Then we did DB-scan on the next slide. And DB-scan is an algorithm where you don't specify the amount of clusters. So this came out with 53 clusters for the A data set and almost 57 clusters for the B data set. And this is just a simple area graph of how the results are distributed throughout these clusters. And then lastly, we did expectation maximization on the next slide, which is sort of an iterative extension on the K-means algorithm. But no matter how many times I ran this one, I was only able to get 1 cluster across both data sets. And that was with several different transformation and resampling techniques. So yeah, that was a pretty solid result for expectation maximization across the board. And that's it for unsupervised learning.
Hi. So this is all about the supervised learning. So here first we will retrieve the data set and then we will it will deliver the copies of to the output pool. So then when the filter operators will use to extract the data. So here first we'll do all the pre-processing steps, and then from there we'll do the set rule, and also from the filter example it will connect to the decision tree, and there we'll apply a model to the output. So that will generate our final output. So here we also use to do a cross validation. So it will connect from the set rule to the cross validation. And this is a random forest of the supervised. So the random forest, the accurate values will almost be predicted here. So here the duration protocol type, SOB, are some of the important factors of the predictor. So, and also for the random forest, the accuracy of the data set A was not that great, but the accuracy of data set B was almost perfect. See, here we can see that the data set A is not that accurate, and we do have the cluster starting from cluster 0 to cluster 7. And here comes the decision tree, and here in the decision tree the accuracy is almost 59.5%. We do have the source byte prediction service and service count over here. And this is the SVM of the supervised learning. So here we'll retrieve the data set, then we'll go to we'll select the attributes, and from there we'll do the set rule. So from the set rule, we'll split the data, and from there we'll do the SVM, so that is a supervised learning, SVM linear regression. And from there we'll apply the model, and that will provide the performance model of this. And here comes the naive bytes. So here we can see that we do have the 41 distributions. So we do have the class back as 0.021, and almost all others were like 0.0, and the class normal is around 0.961, which is almost around to 1. And this is the SVM of comparison of A versus B. Here we do have the classification error as 1.09%, which is the micro average as 1.09. Here we do have the true back values from true buffer and also from true vast values and also the class predictors. So this is the overall result of the supervised learning. So here we can see that the accuracy is almost 88.98%, which is a very good percentage. Okay. Here comes the meta learners. So in the meta learners, we'll start from we'll start from the open file to read A or AFF. And from there, we'll replace missing values. Then we'll do a normalization process. And then from there, we'll do the set rule. So from the set rule, we'll connect to the cross validation and it will connect to the output. And this is a cross validation table. So from there, from the set rule 2, we'll be doing the bagging method. And then from there, we'll connect to the output. And from the output, we'll again test that. And this, this is splitted into both the training and the testing model. So apply model and performance comes under the testing. Right? So here we'll connect the apply model to the performance to get the output. And this is the bagging model. So here for the data set A, the accuracy is almost 98%. And for data set B, the accuracy is around 92.42. So for bagging, we can see that the accuracy for data set A is pretty good. And even for Bayesian boosting, the accuracy is almost 99.06. And for data set A, the random forest is around 98.20. So even from there, we can see that the data set A is better than the data set B.
So for rule-based approach, I unfortunately could not get very far into the study due to my lack of knowledge of RapidMiner. However, I did get to rule induction. You retrieve the data set, you normalize it, and then set a label, and then from there you would use rule induction. And then on the next slide is just an example with data set B. And then on my third slide here are my results from my study. You can see that it correctly produces if-else statements, and it tells you how many are correct out of the training examples. Unfortunately, that is all that I could get through. I did not get FP growth to work. I tried very many methods to no avail. With that, we will move on to the next slide. Thank you.